So what is an atom? An atom is the smallest unit of an element. Okay. Now that word element is any substance that cannot be decomposed into simpler substances by ordinary chemical processes. So if you've seen the periodic table, you've probably seen some familiar things on there, like oxygen, something that we breathe in every day. So oxygen can't be broken down into simpler substances by ordinary chemical processes. We can't do things to oxygen to break it down into anything simpler than oxygen. Okay, so again, an atom is the smallest unit of an element, and again, an element is anything we can't break down into simpler terms. So everything on the periodic table is an element. All right, next let's talk about the atomic mass unit, or AMU. You're going to see this a lot throughout chemistry. So an AMU is a unit used to express the mass of atoms or subatomic particles. Okay, and 1 AMU is equal to 1.66 times 10 to the negative 27 kilograms. That's really small. So remember, when we have a negative 27 power, we are moving the decimal place to the left 27 times, and that's a really, really, really small number. So we're talking tiny here. Subatomic particles are the smaller parts that make up an atom. Now, we already said that you cannot break elements down into simpler things, so we can't take an atom and really break it apart into all these little minor components, but these are the parts that make up an atom. You've got protons, neutrons, and electrons. You've probably heard those terms before in other science classes. So let's talk about these three particles. So first of all, protons are located in the nucleus. Neutrons are also located in the nucleus. Electrons are located in the electron cloud. All right, so if you look at the atom that's pictured up here, we've got the red and the blue circles or spheres in the middle. That would be the nucleus. And orbiting around the nucleus are these gray spheres. Those are representing the electrons. Okay, the electron cloud is that area outside of the nucleus. All right, protons have a mass of 1 AMU. Neutrons also have a mass of 1 AMU. Okay, now electrons, for all intents and purposes, have a mass of 0 AMU, but electrons do have mass. It's just so small that it is insignificant. So for the purposes of our class here, we say that electrons have a mass of 0 AMU. Okay, protons have a charge of +1, positive charge. Neutrons have no charge. And electrons have a charge of -1. It's a negative charge. So protons are easy to remember. Positive starts with the letter P, and we know that they have a positive charge. Neutrons, so neutral, it almost has the word neutral in the name. Neutrons have no charge, they're neutral. Electrons is the one you kind of have to remember. So electrons have a negative charge. Okay, so this table of information you're going to need to know. This is going to come up in other lessons throughout the course, so please commit this to memory. All right, let's talk about the electron cloud. So as I kind of mentioned, the electron cloud is the area surrounding the nucleus. So the nucleus in this picture to the right is that kind of pinkish reddish area in the middle. The electron cloud are all of the blue dots around on the outside. Okay, and overall, the electron cloud has a negative charge. and it consists of mostly empty space. Now we'll come back and we'll talk about the electron cloud a little bit more. It'll make a little bit more sense when we get into the models of the atom. But the electron cloud is basically anywhere the electrons could be. So you look and you notice there's just lots and lots and lots of blue dots, but the electron cloud is just basically anywhere those electrons could be. So there may only be like, 3 or 4 electrons in this atom, but those blue dots are anywhere that those electrons could be. And it'll make a little bit more sense when we get into the different models of the atom. All right, let's talk about the atomic and the mass number. So the atomic number is equal to the number of protons. Protons are what control the identity of the atom. The mass number is simply the number of protons and the number of neutrons. Now remember, the protons and the neutrons both have mass. We say they have a mass of 1 AMU. So each proton has a mass of 1 AMU, each neutron has a mass of 1 AMU. You add all of them up, and that'll give you the mass number. Okay. Neutral atoms are atoms that are neutral if the net charge is equal to 0. So the number of protons is equal to the number of electrons. So let's do an example here. Let's say you had an atom with 4 protons, so that would be plus 4. And then you had an atom with 4 electrons. That would be a charge of negative 4. So you don't have to be a math wizard to figure out that a charge of positive 4 and a charge of negative 4, they're going to cancel each other out. And that's kind of what a neutral atom does. They balance out. So the positive charges and the negative charges balance out. All right, let's do an example. So we have a mass number of 23 and we have an atomic number of 11. So I told you previously that the atomic number is equal to the number of protons, which is 11. Now, let's assume that this is a neutral atom, so the number of protons is going to be equal to the number of electrons. Now, to get the neutrons, remember the mass number is equal to the protons plus the neutrons. So we know the mass number is 23, so that number is going to be equal to the number of protons plus the number of neutrons. Well, we already know that the number of protons is 11. So we just have to do a little bit of math here. So 23 minus 11, move that 11 over to the other side. 23 minus 11 is 12. Running out of space here. So the number of neutrons is going to be equal to 12. Now, if you look on the periodic table and we find the atom, or rather the element that has 11 protons, that is sodium. Sodium has the symbol of Na. It's kind of one of those goofy ones that you just kind of have to remember. And there you go. Okay, so let's talk about notation. This looks awful, right? We got all sorts of letters going on here. All right, so X is the elemental symbol. So in the previous example that we did, sodium was Na. So on the periodic table, the letters that you see are the element symbol. The next letter that we're going to look at is A. A is the mass number. So remember, the mass number is equal to the protons plus the neutrons. That's where the majority of the mass is in our atom. All right, the atomic number is Z. Z is just equal to the number of protons. And finally, B. B is the charge. So the charge is a little tricky because the charge is the overall charge. So that's where we're going to take the number of protons and we're going to compare it to the number of electrons and figure out which is greater, the positive charge or the negative charge. And we'll do an example with this in a minute or here. All right, so here's aluminum. First thing we want to do is we want to look at the atomic number. Atomic number is 13, so that tells us the number of protons. Now, if you notice, there's nothing here. So we're going to assume if there isn't a number here for the charge, this is a neutral atom. So the number of protons is equal to the number of electrons. Okay, next, let's look at the mass number. We're going to need the mass number to find out the number of neutrons. Remember, the mass number is equal to the protons plus the neutrons. So the mass number 27 is equal to the number of protons, which we already figured out is 13, plus the number of neutrons. So to find the neutrons, we're just going to kind of do a little math here. So let's subtract 13 from both sides. So 27 minus 13 is 14. So the number of neutrons is 14. Let's do another one. Okay, here we have chlorine, you know, that wonderful smelling stuff in your pool. So for chlorine, we have an atomic number of 17, which is the number of protons. Again, there's nothing here for the charge, so we assume that we have the same number of protons and electrons, which is 17. Our mass number is 35. 35, remember, is equal to the number of protons, which is 17, plus the number of neutrons. Let's subtract 17 from both sides. 35 minus 17 is 18. So we have 18 neutrons. All right, we're going to do one more example, and you're going to notice the notation's a little bit different here. So here's carbon 14. Now this looks nothing like the previous two examples. So if you ever see an element written out like this, or an atom written out like this 14 is the mass number. Okay. Now, where is the atomic number going to come from? I mean, we kind of needed that, right, to figure out the number of neutrons? Well, if you look on the periodic table, carbon is number 6. So the atomic number is coming from here. You're going to look this up on the periodic table. Okay, so the atomic number is coming from the name. We look up carbon on the periodic table. It's number 6. And when we have an element written out like this, when we have an atom written out like this, we assume that it's neutral. So the number of protons and the number of electrons are the same. Now, to get our neutrons, we know the mass is 14. We're going to subtract out, the 6 protons, and that'll give us our neutrons. So 14 minus 6 is 8, and that is the number of neutrons. And that, in a nutshell, is atomic structure.